Alright, hello guys. We continue using the concept of gradients to establish the equation of a line in the form y equal to mx plus c. I'm sure your teacher has explained the y equal to mx plus c to you. And so the equation of the line is given as y equal to mx plus c, where the m here is the gradient we looked at in our previous lessons. And then the x and y here are the coordinates or the points given to us. And c is the points that the y-axis passes through. That is the y-intercept, alright? And so when we talk about y-intercept, x is always 0 in most cases. Let's take example 1. A straight line has an equation y equal to 4x minus 1. Given this equation y equal to 4x minus 1, we are being asked to find the gradient and the y-intercept of the line. Let's go to the solution. And so you can see, comparing the equation that has been given to us, y equal to 4x minus 1, to the equation of the line which you already know. So this is the equation of the line. It's given as y equal to mx plus c. And so comparing what has been given to us to the equation of the line, we can clearly see that our gradient, which is m, or the slope, which is m, is 4. And then the y-intercept, which is c, is negative 1. And so that is very easy. Let's move on to example number 2. A straight line has an equation 3y equal to 2x plus 12. Find the gradient and the y-intercept of the line. Let's look at the solution. From y equal to mx plus c, which is the equation of the line, we may want to go straight away to, you'll be tempted to say that the gradient is 2, but no. You first have to put it into the form y equal to mx plus c. And so in doing so, we divide both sides by the coefficient of the y, which is 3. And so we divide, here is 3y equals to 2x plus. So we divide each term by the 3. And so I divide here by 3, I divide here by 3, I divide here by 3. I see that my 3 cancels that clearly. I'm left with my y equal to, I get my 2 over 3x plus, when I divide the 12 by 3, I have 4. And so now comparing y equal to 2 over 3x plus 4 to the equation of a line. When we compare, you can see that, okay, my gradient is now 2 over 3. And then my y-intercept, which is the c, is 4. Alright, and so it can be given this way in your objective questions or subjectives. Take notes. And so let's take a complete question as well. Example 3 says that a straight line with gradient 1 over 2 passes through the point k, negative 1, 2. Find the equation of a line. But we know from our previous lessons that if we want to calculate for gradients, we need 2 different points, right? We need 2 different points so that you can be able to identify your first x value, first y value, first second x value, second y value. I mean, when you look at the previous lessons, you get it better. And so here the point was given as just 1 point, k, negative 1, comma 2. And so we have to introduce our new point that let x, comma y be a point on the line. And so now we have 2 points, that is the k given as negative 1, 2, and then our new points x, comma y. That way we can see that, okay, this is our first x value, this is our first y value, this is our second x value, this is our second y value. And then we go back to the gradient formula. If you remember the gradient formula, m equal to y2 minus y1 all over x2 minus x1. And then we do the substitution. And so wherever we see y2, we put y. Our y1 is 2. Our x2 is x minus our x1 is negative 1. And so we quickly do the cross multiplication. And so 2 multiplies that, and we can see. And then x minus minus 1. I told you your integers have to be solid. So negative negative is positive. And so this becomes x plus 1. And then we learn to expand the brackets. And so 2 multiplying y, we have 2y. 2 multiplying negative 2, we have negative 4. All equal to x plus 1. Now when we decide to take all the terms to one side and equate it to 0, we have 2y. When the x jumps, it becomes negative. When this positive 1 jumps, it becomes negative 1. Negative 4 minus 1, integers, is negative 5. And so we have 2y minus x minus 5 equal to 0. You can leave your answer in this form, it will be marked correctly. Or you may want to leave it in the form y equal to mx plus c. That is also acceptable. And so when we do that, we can take our x and 5 back. When we do that, x will become positive, 5 will also become positive. When we divide both sides by the coefficient of y, that is 2. And so it becomes y equal to x over 2 plus 5 over 2. Think about it, huh? Think about it and get it. And so now, the II is an interesting question you should take note of. Because it normally doesn't really count. And so you check it out. You say the value of m if the point C, a new point has been given. And so if the point C, 3, m, you remember we drew on a graph sheet and then we drew the straight line, we saw a number of points, alright? And so k being negative 1, 2 is a point on that line. And then x, y that we introduced is a point on that same line. And so 3, m, they are also saying it's a point on that same line. And so now they are saying we should find the value of m if the point C3, m is also on that line. And so we come back to our solution here and say, okay, given C 3, m, and then the equation of the line that we just found. Since they say 3, m is on that line, it must satisfy it. In that quest, this 3 is our x value, this m is our y value. So we just do the substitution. If I pick this, I'll get the same thing. But because I want the work to be easier, that's why I picked 2y minus x minus 5 equal to 0. That way, wherever I see my y, I substitute with m. Wherever I see my x, I substitute with the value 3. And so when we do that, 2 times m gives us 2m. And then the negative 3, because there will be 3, negative 3, negative 5, your integers once again must be negative 8. When it crosses the equal to sign, it becomes positive 8. And so take your time and think about it. And so this becomes 2m equal to 8. You divide both sides by 2, m is equal to 4. Thank you for watching.